A stork drops into a flooded rice paddy outside Toyooka in northern Hyogo Prefecture, lifts a brown frog from the shallow water with its long red bill, and swallows it whole. The bird stands 1.1 meters tall, its black flight feathers ruffled against the wind off the Maruyama River. The paddy below its feet has not been sprayed with a single insecticide in more than a decade. 3 frogs and a loach move across the mud where the stork stepped. In May 1971, in the same valley, Japan watched the last wild Oriental White Stork die. For 34 years after that, the wild population of Japan's national bird stood at 0. Today, the number is more than 550. The story of how that happened is also the story of how Japan stopped spending hundreds of millions of dollars fighting rice pests and started letting 3 birds do the work for free. It begins with what the chemicals did. In the 1950s, Japanese rice farming modernized with industrial speed. Drainage was deepened. Land was consolidated into blocks suitable for machinery. Mercury-based fungicides and organophosphate insecticides were sprayed across every paddy at full federal subsidy. Yields climbed, frogs disappeared, loaches disappeared, dragonfly larvae disappeared. The Oriental White Stork, a 4-kilogram carnivore that fed at the top of the paddy food chain, absorbed mercury into its tissue until its eggs stopped hatching. By the late 1960s, only a few wild storks remained, all in Toyooka. The last of them was captured in May 1971 and died inside a breeding facility months later. The Japanese Crested Ibis, called Toki, walked the same path. Its pink-tipped wings had been a national symbol since the Edo period. The same pesticides that killed the stork reached the ibis through fish and frogs in rice paddies. By 1981, only 5 wild toki remained anywhere in Japan, all on Sado Island in the Sea of Japan. They were captured for an emergency breeding program. The last native-born Japanese toki, a 36-year-old female named Kin, died on Sado Island in October 2003. The Grey Heron survived, just barely. It was pushed out of conventional rice country for decades, retreating to remnant wetlands and shrinking in numbers. Regional rangers had been quietly tracking since the 1960s. 3 birds, 1 ecosystem, 1 chemical war. The first attempt to bring the stork back began in 1965, 6 years before the wild population was even fully gone. Hyogo Prefecture captured the surviving Toyooka birds and tried to breed them in captivity. The program failed for 25 years. The captive storks' bodies were too damaged by mercury poisoning to reproduce. The turning point came in 1985 when the Soviet Union transferred 6 young storks from Khabarovsk Krai. The Russian birds had not eaten Japanese rice. 4 years later, in 1989, the first chick hatched in captivity. By 2002, the captive population had passed 100. In September 2005, 5 storks were carried in wooden boxes onto a managed paddy outside Toyooka and released. 2.5 years later, a wild-born chick hatched there for the first time in 46 years. But 5 birds in one valley could not survive in a landscape still saturated with chemicals. So Toyooka City and Hyogo Prefecture changed the landscape. They wrote a contract with local farmers. The deal was specific: reduce pesticide use by 75 to 100%. Sterilize rice seed in hot water instead of fungicides. Flood the paddies deeper, hold the water longer. Farmers lost about 25% of their rice yield in the first seasons. In exchange, the city paid them 7,000 yen per 1,000 square meters to participate. The harvested rice was sold under the label Stork Natural Rice for between 23 and 54% above the conventional price. That part of the story is well known. What happened in the soil and water of those paddies is less known. Researchers at the Center for Toki and Nature Restoration at Niigata University, including Chihiro Endo and Hisashi Nagata, began long-term monitoring of what returned to the paddies after the chemicals stopped. Frogs returned within 1 season. Loaches and Tanishi snails returned within 2 seasons. Dragonfly larvae came back in numbers nobody had recorded since the war. and spiders, the small, generalist predators that hunt rice plant hoppers, and the pecky rice bug Stenotus rubrovitatus, exploded in density. A 2011 study by Kobayashi, Takada, and Washitani in the journal Basic and Applied Ecology took spiders from active rice paddies during the spray window in early August. The team ran DNA analysis on the gut contents of 1,199 spiders from 3 families. They included wolf spiders in the Lycosidae family and long-jawed orb weavers in the Tetragnathidae. Bug DNA showed up across all 3 groups. The spiders were actively eating Stenotus rubrovitatus, the single most economically damaging pest in Japanese rice. A follow-up study at Kabukuri Numa in Miyagi Prefecture in 2014 measured spider density in winter-flooded paddies against conventional ones across the same August window. The chemical-free paddies held significantly more spiders before, during, and after the spray season. The pests had nowhere to hide. The storks were not eating the plant hoppers. They could not. They eat frogs and fish. The herons stalked the same prey. The ibis hunted aquatic insects and small invertebrates in the shallow water. The birds were not the mechanism of pest control. The birds were the indicator that the mechanism was working again. That distinction is what made the program economic. The Japanese Ministry of Agriculture spent decades treating insects as enemies to be killed. Through the Midori Act, passed in 2022, the same ministry now allocates approximately $89 million every year to pay farmers to use less chemistry and more biology. Cumulative public spending on chemical pest control subsidies and the reintroduction infrastructure connected to it has exceeded $300 million across the last decade. The math no longer veered chemicals. Toyooka's stork-friendly program alone has generated approximately 8 billion yen, roughly $75 million, in ecotourism, construction, and conservation activity. Annual recurring ecotourism returns add another billion yen. The town that once shipped its last wild stork into a breeding pen now lives partly on the fact that storks have come back to it. A photograph displayed at the Toyooka Konotori Park shows a 1959 farmer standing on a flooded paddy embankment with a pair of wild storks behind him. The man is not looking at the birds. He is bent down checking the rice. Within 12 years of that photograph, every wild stork in Japan would be dead. 65 years later, in the spring of 2024, a Toyooka farmer photographed a wild-born stork chick on a nest above the same paddy his grandfather had once treated with mercury. Sato Island took the same approach and scaled it. By 2016, a quarter of all rice acreage on the island had been certified under the Crested Ibis Certified Rice Program. Mako Igarashi of the Sato City Agriculture Department has noted that the island operates about 8,000 rice farms across an area of only 330 square miles. Most farms are smaller than 2 acres and are worked by an aging population. Farms that join the certification cut pesticide use by at least half. Toki sightings and annual foraging surveys conducted by Niigata University climbed every year between the 2008 reintroduction and 2024. By 2020, the wild population on Sato had reached 450 birds. By 2025, toki were regularly photographed feeding in the same hillside terraces where the species had last been seen in 1981. In Miyagi Prefecture, on the eastern side of Honshu, a third pattern emerged. The Kabukuri Numa wetland and the rice paddies around it were jointly listed under the Ramsar Convention in 2005. It remains the only Ramsar site on Earth that officially includes working rice paddies inside its boundary. The local farmers cooperative, led for decades by Masayuki Kureichi, pioneered Fuyu Mizutambo, the practice of flooding paddies in winter to provide habitat for migrating waterfowl. Up to 200,000 white-fronted geese, 1,300 bean geese, 400 swans, and 3,000 ducks now winter on those paddies every year. 60% of all white-fronted geese migrating to Japan now spend the season at Kabukuri Numa. The pecky rice bug populations there have collapsed. Grey herons hunt in numbers the regional rangers had not seen since the 1950s. The same study that measured spider densities found chironomid larvae and other small prey, rebuilding the food web from the bottom up, supporting both the spiders that killed the pests and the herons that signaled the return of the system. As Korechi put it in a project report for the Global Environmental Research Journal, restoration through the managing of rice paddies under cultivation as agricultural wetlands can be a realistic and effective method for restoring natural wetland environments in Asia. 3 regions, 3 birds, 1 pattern. Stop fighting the ecosystem. Pay farmers to let it work. Watch the birds come back as the chemicals leave. The math is simple now in a way it was not 50 years ago. A pesticide application against the pecky rice bug costs the farmer real money every season and damages the food web that suppresses the pest in the first place. A winter flood costs almost nothing, attracts wild geese that fertilize the soil, and rebuilds the spider population that hunts the bug for free. A child standing on a paddy embankment in late summer near Toyooka can now watch a stork lift from rice it never knew it could nest in, fly over a hillside its ancestors crossed 5 generations ago, and disappear toward a coastline that Edo period maps used to mark as stork country. On Sado Island, a toki feeds in a terraced field cut into a mountainside above the village, where its species was last captured alive in 1981. At Kabukuri Numa, a gray heron stands knee-deep in a paddy where 200,000 geese will arrive in November. None of the birds know any of this. They only know that the water is shallow enough, the food is alive, and nothing in the field is killing them. The same can be said of the rice.